of inventory through production consumption model, that is the industry model. In this sense, the item is produced in the factory and consumed in the industry itself for assembly or directly given to the customer. In this case, the production is performed for certain time and then it is consumed throughout a certain period. In factory, the machines are operated for short period T1 and the production will be produced at the rate of P for time T1. During the same period, there is a demand also. So the actual inventory available at the end of the period T1 will be P minus D. If the production rate is higher than the consumption rate D, then we will not produce all the time, that is for T1 plus T2, but produce for a certain time T1. During this period T1, the items are produced at the rate of P and consumed at the rate of D, and therefore during period T1 the inventory is built up at the rate of P minus D. So here this represents the building up of inventory, and at the end of the period T1 we have inventory equals to, let's say, I. So this is the inventory at the end of period T1, and now this inventory is consumed without any production for the next time T2. During period T2, consumption rate is constant, that is equal to D. During this there is no production, so we are consuming I. This I will be equals to the P minus D. So this is P minus D. From this we consume it from P minus D to 0, and then again the production will start again. Q is the total production, is given by production rate multiplied by time. Production rate is P over the time T1, so total production is Q equal to P into T1. Average inventory is given by area of this triangle divided by cycle time T1 plus T2. Area of triangle is given by half into I multiplied by T1 plus T2, and the cycle time is T1 plus T2. So we have average inventory equals to I by 2. So average inventory cost is 1 by 2 into, that is average inventory multiplied by holding cost, is 1 by 2 I into CH. Number of orders per year is same as the number of batches produced, that is how many batches we have to produce. So that is equals to demand divided by Q. If CO is the order cost or CO is the setup cost, then the annual order cost or setup cost will be given by the number of times we have to reset the machine, that is D by QO multiplied by CO. Total cost is average inventory cost plus the setup cost, that is annual order cost, equation 1 plus 2. We will eliminate I. During period T1 the production rate is P, so total production will be equals to Q is given by production rate P multiplied by T1, and during this we have a production and a consumption also. So the net inventory that we develop is P minus D over the period T1. So we have I is equals to the rate of production minus consumption, that is P minus D multiplied by T1. Therefore, if we take a ratio, I by Q is P minus D divided by P, or we can solve for I as Q P minus D upon P. So P minus P is 1, D by P is 1 minus D by P. So I equals to Q 1 minus D by P. So if I put this value of I in equation 1, the total cost will be equals to 1 by 2 Q into 1 minus D by P multiplied by CH, and the order cost is D by Q by CO. To find out economic order differentiate with respect to Q and equate to 0. 1 by 2 derivative of Q is 1 minus D by Q P into CH, and plus D by CO derivative of Q is minus 1 by Q square. So we solve for this, we will get economic. So we are again getting the same equation that we have developed initially. This is 2 times we have demand multiplied by CO, that is order cost, divided by the holding cost. Only thing that the denominator is multiplied by 1 minus D divided by P, where D is demand and P is the production rate. This is the economic model for the production consumption without shortage. Economic order quantity with the same production consumption but with shortage, so we have to just we will use the same formula, only thing that we will multiply it by CH plus CS upon CS, where CS is called as shortage cost. So this is with shortage and this is without shortage.